Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Pierced Cages by MD88 Keys, or as I like to call them, Dr. Piano. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We also have digits on an arrow sum to the number in the attached circle, and these arrows are piercing these killer cages. For all of them, I think, actually. So, for example, if you had, say, 1, 3, and 4 here, this would have to be an 8, because these three digits must add up to the digit in the attached circle. And that's an example of how arrows work. And we also have digits in a cage sum to the number given. So these three digits must add up to 19, these three must add up to 8, these three must add up to 6, etc., etc. So, for example, you could have, say, 3, 7, and, 3, 9, and 7 there. Well, that's not going to work. 7, 9, and 3 there. And this would be valid because 3, 9, and 7 add up to 19. And that's an example of how killer cages work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, first thing that comes to my mind is this 23 cage, which must be the digits 6, 8, and 9 added up, because the only way 3 unique digits can ever add up to 23 for normal Sudoku is if you have 6, 8, and 9 there. And 8 and 9 can never add up with 2 other unique digits to add up to a single digit, right? 8 at minimum with 1 and 2 adds up to 11. 9 with at minimum 1 and 2 add up to 12. So therefore, this must be 6. This is 8, 9 as a pair here. And 6 plus 1 and 2 adds up to 9 at minimum. And 9 is the maximum a digit can be, obviously. So this must be the minimum here, adding up to the maximum value here. So this cannot be 9. We know that this digit cannot be 6 or 9. Okay, so any digit which adds up to, which is the sum of 3 unique digits, must be 6 through 9. So these are all 6 through 9, but this can't be 6 or 9 here, so this must be 7 or 8. It's the same with these. These cannot be 9, so this is 7 or 8, 6, 7, or 8 there. 6, 7, 8, 9 there. 6, 7, or 8 here. 6, 7, or 8 here. And this could be 6 through 9. Well, anytime... Well, let's do this upper central box here. We have a 1, 2 pair in the box and an 8, 9 pair in the box, which means the remaining digits in this box are 3, 4, 5, and 7. Okay. Anytime you have 3 unique digits adding up to another digit, and it's not 9, it must have a 1 there, right? 1, 2, 3 is required to add up to 6. 1, 2, 4 is required to add up to 7. And 1, 2, 5 or 1, 3, 4 is required to add up to 8. So we definitely have a 1 here. 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 So same thing here. This is a single digit, 8, adding, and we know this has to be a 1, 2, 3 triplet here to add up to 9. Again, one of these digits is a 1 here, so this cannot be 1. Which means 1 can't be here, because we have a guaranteed 1 here. Also, these digits add up to a single digit here, so that also must have a 1. Well, where's the 1 going to be then in this box? It must be here. because this doesn't add up to 9, so it requires a 1 on this arrow, and this cage also adds up to 8, so it requires a 1 there. Well, to add up to 8, you have to have it's either 2, 5, or 3, 4. But that would leave the remaining digits in the box also having at minimum 2, 5, or 3, 4. So this must arrow here must add up. First of all, this can't be 1. But this arrow must add up to 8. Because we have 2, 5, or 3, 4 here. But that leaves the remaining digits on this arrow as minimum 2, 5, and 3, 4. And that minimum adds up to the maximum value that can be there. So we know this is 8. This can't be 8 here. So this must be 2, 5, or 3, 4 here. This is 2, 3, 4, 5. This is 2, 3, 4, 5. And if this were 6, this would have to be 1, 2, and 3 here. But that would eliminate all possibilities for this cell in this box. So this cannot be 6. This must be 7. That eliminates 7 from here. This must be 1, 2, and 4, adding up to 7, which eliminates 1, 2, 4 in the rest of the box. This can't be 2. It's 3, which eliminates 3 here. This is 1, 2 as a pair. Where is 3 in column 5 then? Cannot be here because it's 6, 8, 9 for the cage. 3 also eliminates 3 here, and it can't be here because of 3 in the box, so 3 has to be these digits here. So it must be 1, 3, and 4, adding up to 8 here, which means this is 1, 2, and 5 here. Since this is 1, 3, 4, that eliminates 1, 3, 4 in the rest of the column. So this must be 2 here. There's no 2 here, no 2 here. This has to be then 5 and 7, adding up to 14 because of what's already eliminated. This digit cannot be 1, 2, or 4. Therefore, this must be 3 or 5 here. Because it must add up to at most 8 here. And the highest digit you can have for 3 unique digits adding up to an 8 or less is 5. So that's why this is 3 or 5 here. It cannot add up to 7 now because 7 must be the digits 1, 2, and 4 adding up uniquely. So this must be 8 here. So we have 1 here or 2, 1, 2, and 5, or this is 1, 4, and 3. So this could be 2 here or 1 here, and this is 2. So we guarantee you have a 1 in one of these two cells. This cannot have 1, 2, or 4 also, so this is 3, 5, or 6 there. Because to add up to 9, you could have 1, 2, and 6 potentially. 6 is the largest digit, I guess I should say. This digit cannot be 1, 2, or 3 because of the 1, 2, 3 triplet in the row. So this must be 4, 5, or 6. It cannot be 6 here because it doesn't add up to 9. So this is 4 or 5 here. This cannot be 1 or 2. So this is at least 3 here. Well, we know this is minimum then 3, 1, and 4, which adds up to the maximum this digit can be, which is 8. So that this minimum must be the correct answer. So this is 1, this is 3, that's 4, which adds up to 8 there. 1 eliminates 1 here, and we need to have a 1 in this arrow here. So this is 1 here, that's 2. Where is the 2? So this adds up to 12 here. It does not have 3 and 8, so it can't be 1, 3, 8. It does not have a 9, so it can't be 2 and 9. So this could either be 1, 4, 7 or 1, 5, 6. 7 can't be here, so this can't be 4. 8 here eliminates 8 here, so this is 9, which makes that 8. Where is the 2 in row 6? Can't be here because of 2 in the boxes. It must be here. And therefore, this adds up to 12 with a 2 involved. It cannot So the possibilities with 2 are 129, 237, or 246. Well, we can't have 7 here, so that eliminates 237 because of 7 in the box. We can't have 4 here because of 4 in the box, so this must be a 129 triplet. And 9 cannot be on the arrow to add up to another digit with another digit. And this 129 triplet eliminates 9 in the rest of the box, so this can't be 9. So this can no longer have a 6 here, because if this were 6, it's not going to add up to 6 or 8 here. We have a 3-5 pair in row 5, which eliminates 3 and 5 in the rest of the row. So that leaves 6, 8, and 9 remaining in row 5. This can't be 9 because of the 129 triplet in the box. So this is now a 6, 8 pair here. 8 eliminates 8 here, so that's 6, which makes that 8. This can no longer be 6 here. This 8, 9 pair eliminates 8 and 9 in the rest of the box here. So this is 6 or 7. To add up to 6 or 7, we need, it's either 1, 2, 3 or 1, 2, 4. And 1 can't be here, 1 can't be here. Where is the 1 then on this arrow? It must be here. So we're guaranteed a 2, a 3, or 4 here. If it's 2, this is 8 and 9. And so you would have to have 8 and 9 there. If this is 3, this is 7, 9 as a pair, which could work. 4 could be with 6, 9, or 7, 8. So those are the possibilities there. 2 eliminates 2 as a possibility here. This must add up to 6 or 7, so we're guaranteed a 2 here, which means this is 8 and 9, adding up to 19. So that's 8 and 9. 8 eliminates 8 here, so it's 9 and 8. Yeah, the 2, 5 pair eliminated 2 there, which is why that can't be 2. This is adding up to 8 here. It could be either 1, 3, and 4, or 1, 2, and 5, but this can't be 2 here, so this would be 1 or 5. Okay. And now we just have to do normal Sudoku. Okay. We have a 1, 2, 4, 5, 7 sextuplet in quintuplet in column 6, which eliminates 1, 2, 4, 5, 7 in the rest of the column. So this must be 6, 8, and 9. This can't be 8 or 9, so therefore this is 6, which means this can't be 6. This can't be 9 because of the 1, 2, 9 triplet in the row. So this is 8, which makes this 9. That means 7 is one of these two digits here, so 7 cannot appear in that box there. Remaining digits in the central box are 6 and 9. This can't be 9 because of 9 in the row, or the 1, 2, 9 triplet in the row. So this is 6, this is 9. 6 eliminates 6 here, so it's 7. 1, 2, and 4 add up to 7. So this is 7 here. Remaining digits in this lower central box are 7 and 8 because of the 3, 4 pair and the 2, 5 pair. This can't be 8, so this is 7, which makes that 8 there. 7 eliminates 7 here, so it's 5 and 7. Remaining digits in row 6 are 3 and 4, which eliminates 3 and 4 in the rest of the box. This can't be 3, it's 5, which eliminates 5 here, so that's 3, which leaves that as a 5 there. This adds up to 8. It must be 3, 1, and 4. So this is 1, that's 4. This can no longer be 1 or 9. So this is 2, which makes that 9. 5, 1, and 2 add up to 8. So this is 2. Where is the 1 in row 6? These are all filled out, and this can't be 1 because of 1 in the box. This can't be 1 because of 1 in the column, so 1 has to be there. Where is 1 in column 8? Cannot be here because of 1s in the boxes. Can't be here because of 1 in the row. Can't be here because of the 1, 2 pair in the row here, so 1 has to be there. 2s. Where is 2 in this upper left-hand box? It cannot be here or here because of 2 in the column and the 1-2 pair in the, sorry, 2 in the row and the 1-2 pair in the row. And it cannot be here because of 2 in the column. So 2 has to be there. Where is 2 in column 7 or column 1? Can't be here because of 2 in the row. Can't be here because of the 2-5 pair in the row. So 2 has to be there. This 5 eliminates 5 from being there, so this correspondingly cannot be 6 because this must be 4 and 7 or 5 and 6 to add up to 12. This 4 eliminates 4 here, so that's 3 and 4, which leaves the remaining digit in row 7 as a 5 and the remaining digit in column 1 as a 7. Okay. 2, 3, we don't have enough info. Well, no, 3 in column 3 has to be here. We don't have enough information for the rest of the boxes. 4, the remaining digits of column 3 are 4 and 6. So this has to be 4 or 6. Remaining digits of this lower left-hand box are 6 and 9. This can't be 9 because of 9 in the row. So this has to be 6 here. This is 9. That leaves 5, 7 remaining in column 2. In row 9, we have 5 and 7 remaining. 5 is eliminated because of 5 in the column here. So this is 7. That's 5. Remaining digits of row 8 are 3 and 6. Remaining digit of row 4 is a 6. Remaining digits of column 9, we have 3, 5, and 9. Well, 9 cannot be either of these, so 9 has to be here. This can't be 3 because of 3 in the row, so it's 5 and 3. 5 eliminates 5 here, so it's 7 and 5. 1, 5, 6 adds up to 12, so this is 6, that's 4. 3 eliminates 3 here, this can't be 4, so that's 5. No 4 or 5 there, so it's 7. 5 eliminates 5 here, so it's 2 and 5. 2 eliminates 2 here, so it's 1 and 2. 1 eliminates 1 here, so it's 4 and 1. That leaves this not as 4 or 5, it's 3. This can't be 5 or 7, because of 5 or 7 in the column, so that's 4. That leaves this remaining digit in row 1 as a 6, which eliminates 6 here, so it's 3 and 6. That 3 eliminates 3 here, so it's 4 and 3, which leaves that as a 7 and that as a 4. Interesting use of the arrows with the cages. You'll often run into these types of puzzles quite a bit, actually, with 3 digits adding up to a single digit. They happen fairly often. It's a very common restriction that setters seem to like to place, which makes sense because you can convey a lot of restricted information with that. So it's good to have in your mind or knowledge the ability of knowing which digits add up to which sums, right? For a single digit. So I have that pretty well locked in for myself because I've done it so many times. So that's something that you should always keep in mind. Yeah. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.